in our work with linear equations in two variables so far, we have gone from the equation to the straight line that is the picture of the solutions to that equation. Remember, a linear equation in two variables has an infinite number of solutions. We could never list all of the solution pairs. So what we do is we find some of the solution pairs, we put them on our graph paper, draw the straight line that contains those solution pairs, put an arrowhead at each end to indicate that that set of solutions goes on indefinitely. And this is the pictorial representation of it. Well, what if we know some solutions to an equation, but we don't know the equation? Can we somehow get from the solutions, get from the line back to the equation? We've gone from equation to line. Now, can we get from line to equation? And the answer is yes. In fact, would have I asked the question if we couldn't? Right? It wouldn't be much work for us to do here in this video and in your assignments if we couldn't make that move from solutions back to equation. In order to do that, we're going to concentrate our efforts on the slope-intercept form of the linear equation in two variables. Remember, the slope-intercept form has the y value, the y term all by itself on one side of the equation with a coefficient of positive 1. The x term, which has some coefficient, and remember that coefficient is the slope, isn't it? Remember that from a previous video? The coefficient of x is the slope of the line, and it has some constant value, which mathematicians use the letter b in the slope-intercept form to represent the constant value. And remember what that constant value is. The constant value is the y-intercept. So if we can figure out what numbers go in place of m and b from the information we have, which in this case is solutions, points on the line, we can figure out the equation that goes with that line. Well, one of those quantities is the slope. What did we learn earlier? If we have points on the line, we can figure out what the slope of the line is. Because remember what slope is. Slope is change of y divided by change of x. So given points on the line, we can figure out the slope of the line. And we will have our value for m. Well, if we look at, let's say, look at these 2 points on the line. Going from the point 27 to the point 39, the y is going from 7 to 9, which is a plus 2 change of y. And the x went from 2 to 3, which is a plus 1 change. So the slope of that line is a slope of 2. And we now know that our equation has a 2 here for the coefficient of x. The coefficient of x, that would be the equation matched up to this line, would be a slope of 2. Our equation then, so far, looks like this. And all we have to do is figure out what would be the y-intercept, what would be the b value. Now, I suppose we could try to do that graphically, but it might be tough to be very accurate. So we need a different approach in order to find that y value of the y-intercept point, in order to find that b. Well, think about it. These points are solutions to this equation. Well, doesn't that mean that whatever this number is, if I put one of these points in for x and y, doesn't this number have to make it work? And what I mean by make it work, this number, whatever it is, will have to make it so the left side becomes the same as the right side. So let's pick one of the points. Let's take the point 3, 9. And let's put the 3 in place of x. And put the 9 in place of y. And now look what we've created. We've created a linear equation in one variable that we can solve. And that will tell us what the b value has to be to make the 0.39 solve the equation. So 9 equals 6 plus b. B has to be 3. And now we know our equation would have to be y equals 2x plus 3. The technique we used then was to take the information we were given and first of all find the slope of the line, because we were given points on the line, and then take that new slope along with one of the solutions to find the b value, the y-intercept value. And that's how we were able to go from line back to equation. And if we check these points, we'll see that those points would be solutions to that equation. If x is 2, 2 times 2 is 4 plus 3, the y has to be 7. If x is 1, 1 times 2 is 2 plus 3, the y has to be 5. If x is negative 1, 2 times negative 1 is negative 2, negative 2 plus 3 is 1. And we have found the correct equation that goes with those points on that line.